Here's another example involving using the one-to-one property to solve an exponential equation. In this example, I have 1/5 raised to the x plus 1 power equals 125. And the big idea here is that there is only one value of x that will work, where I can take 1/5 raised to this x plus 1 and get this value. So just to do a quick little review here, the one-to-one property states that if a to the x equals a to the y, then it has to be the case that these exponents are exactly the same. So if the bases are the same, there is no way that these two quantities could equal each other unless my exponents are also the same. So there's two ways to think through this problem, and I'm going to show you both. One way to think of it is to start, so what we need to do is we need to get both of these written in exponential form, both the left and right hand side. And with the 125, the thing that should jump out at you is that, okay, so 5 to the first would be 5. 5 squared is 25. 5 to the third is 125. How did I know to work with 5? Well, there's a 5 over here, so it's kind of a little hint that, maybe this involves 5 somehow. So instead of saying 125 over here, let's just write that as 5 to the third. So 1/5 raised to the x plus 1 power equals 5 to the third. But notice, this states that my bases need to be exactly the same. On this side, I have a base of 1/5. On this side, I have a base of 5. Those are not the same. So what am I going to do? Well, I'm going to use a little trick here with my properties of exponents, and I know that 5 to the third is the same exact thing as 1 over 5 to the negative third power. Typically, when you use this property of negative exponents, typically you go from here to here. You'll have 5 to the negative third is equal to 5 to the third power. Usually the goal is to get rid of the negative, but this is kind of just going backwards. If I wanted to introduce the negative, I can say that 5 to the third is 1 over 5 to the negative third. And from there, I can say that 1 over 5 to the negative third is actually the same thing as 1/5 to the negative third power. So there's no harm in putting a -3 on this. 1 to the negative third power is still 1. I'm not changing the value. And if the top and bottom are both raised to the negative third power, this is 1/5 to the negative third. So 5 to the third is the same as 1/5 to the negative third. And this side over here is still 1/5 raised to the x plus 1 power. My bases are now the same. They're both 1/5. Let's use this one-to-one property. If a to the x equals a to the y, then x equals y. If 1/5 raised to the x plus 1 equals 1/5 raised to the negative third, then it has to be the case that x plus 1 is equal to -3. Let's subtract 1 on both sides. X would have to be -4, and we're done. Just to do a quick check to make sure that this math works out. You can type this in your calculator. 1/4 plus 1 is -3. If you take 1/5 to the negative third power, well, you can basically use this to see that it's the same thing as 5 to the third. It's the same thing as 125. Now, I told you at the beginning of the video there were two ways to think through this. Here's the other way. So in this problem, in this with this work that I have here, I wrote both sides so that they have a base of 1/5. Let's write both sides so that they have a base of 5. So I'm still going to substitute in 5 to the third for 1/25. But now, instead of manipulating my right-hand side and writing it with a base of 1/5, let's take this side and see if I can write it with a base of 5. So 1/5 raised to the x plus 1. Well, I know I have a property of exponents that states that I can basically distribute this exponent to the numerator and denominator. So this is the same thing as 1 to the x plus 1 power over 5 to the x plus 1 power. 1 to the x plus 1 power, 1 to anything is always 1. So that's just wiped out. So now I have 1 over 5 to the x plus 1 power equals 5 to the third. Let's use my negative exponent trick here. 1 over 5 to the negative x plus 1 is the same exact thing as 5 to the opposite of x plus 1. So just to be very clear here with what I'm doing, as an easier example, if I have 1 over 5 to the, I don't know, 7th power, I can rewrite that as 5 to the negative 7th power. So basically, if I move this um, to the numerator, I got to add a negative sign, or I got to take the opposite of my exponent here. And that's all I'm doing here is I'm rewriting this so that my 5 is in the numerator, and I'm taking the opposite of this exponent right here. 5 to the negative quantity of x plus 1 is equal to 5 to the third. Let's distribute that negative. This is 5 to the negative x minus 1 power. I have the same exact base here. Let's use the one-to-one property. Negative x minus 1 is equal to 3. Add 1 to both sides. Negative x is equal to 4. Divide both sides by negative 1. And our final answer is that x is equal to negative 4, which is exactly the same thing when we worked out the problem where we wrote it where both sides had a base of 1/5.